So finally we start our course. So you can ask yourself, why actually this course? And I'm happy to see that the room is almost full. Even people do not find the right places to sit down. So it seems that it's an important and attractive topic. And it is. So that's why we are here. And let's have a look on energy supply and consumption, not from the point of view of today, but from some distance. And that you can see on this nice picture. When we look, let's say, 2,000 years back, people on this earth were using only solar energy. They didn't know about oil, and they didn't know about, let's say, other primary sources of energy. The only source was sun and its energy. Then, let's say, about 150 years ago, new energy sources were developed, like oil, gas, and other fossil fuels, coal. And we started to produce energy from these sources. And actually today we are at the maximum of using these sources. We call them at this moment traditional energy sources, and these are coal, oil, and gas. We know that these sources will be depleted, and that's why the use of these fossil fuels will be decreasing. And I will show you predictions that this will happen, let's say, in 10 or 20 years' time. Then we will be really depleting the source. So we will sooner or later come to the era where again the sun will be the only source of the energy. To give you a picture how the energy is produced today, here are some pictures. This is from 2004, but the picture has not changed in 3 years much. So you see that we generate at this moment around 500 ettajoules, and about 80% of this energy is generated from these traditional energy sources, like coal, gas, and oil. Only about 15% comes from other sources. What are these 15%? Mostly nuclear, then hydropower, traditional biomass, so for example burning wood, and then what we call renewable energy sources. And what we mean by renewable energy sources, it is solar thermal, wind, biofuels, geothermal, and also solar PV, solar cells. And you see among the renewable energy sources, PV does not play an important role yet. But this is changing very quickly. By using these fossil fuels, we are generating ourselves problems. And you are aware of two major global problems that the mankind faces today. One of them is the shortage of energy, and this can be shown that there is a problem by increasing the price of oil. And I read yesterday that there was a new record. 1 barrel of oil costs $112, so a new record, and this will go on. But what this means is that also the electricity that we generate from these sources, the price of the electricity will also go up. And then it's the climate change. Well, there is a lot of discussion whether really the man is responsible for climate change. Many experts say yes. And recently, you know about many floodings. Here is an example. At the end of November in 2007, the flooding in Mexico. So there are these two big problems, and we have to face them, and not only face, but try to find solution. We are responsible for them, so we have to find a solution. One very important solution is that we start to use the energy efficiently. People talk a lot about it, but they don't do it. And it means simple things. When you leave the room, that you switch off the light, things like that. Just start with yourself. And the second is to introduce on large scale renewable energy sources, like the one I discussed already, photovoltaics, thermal, solar power, hydropower, and other renewable energy sources. So these are just nice pictures of depleting energy sources, like you see oil platform in sea, this is nuclear power station, and this is then coal power plant, and you see these nice clouds that actually contribute to this climate change. And so, as I'm saying, for last 150, 100 years, people were looking for energy down in the earth. Yeah? And they have found a lot of supplies of oil and coal, and we are using them now. But now it's time to look up, to look at the sun. So, when we have a bright day like today, we see the sun, how it shines. We even cannot look directly in it, and it gives us a lot of energy. I shall show you how much energy actually arrives from the sun to the earth. So the question is, can we get solar electricity from the sun? And is it worth doing it? And the question is, yes, of course. We are also here that we believe in it. And why? Because we believe that it is the energy of future, and also because it contributes to cleaner climate. And here are some examples of solar cells, because these solar cells already exist. The first solar cell was made in 1956, so many years ago. It was a small cell, and they were used in space applications. Today, I will show you, solar cells are the fastest growing industry in the world, and also the fastest emerging renewable energy. So you see that we can already produce such big solar cells and cover the roofs and generate electricity from it. That we are here, or me, not the only ones who believe that the sun will become the most important energy source. Here is a study that was asked by the German government on global climate change. And in this study, the experts looked on the energy consumption in the world and also how to generate energy. These three colors, what you see in this picture, this is energy coming from fossil fuels. We are somewhere here, 2008, and as you can see also in this graph, fossil fuels are the dominant energy source. But as I already explained, these are depleting energy sources, and we expect that in 20 years, around 2030, there will be a maximum of producing energy from these sources. Then it will be decreasing. So we have to find a gap between energy demand, number of people on the earth is growing, and they all want to live comfortably and use energy. And the experts predict that the energy gap has to be filled by renewable energy sources. Let's say in 2030, 40, photovoltaics and solar energy starts to play an important role. And they also extrapolated it to 2010 and you see 2100, and you see that experts expect that solar energy will be the dominant energy source. So you are becoming the experts in this area, and I'm sure you will have no problem to find a job in this area when you finish school. So why solar cells? Sometimes I use the name solar cells and sometimes photovoltaic. Actually, photovoltaic is another word to describe the world of solar cells. And this photovoltaic energy conversion will become the important energy source. the photovoltaic energy conversion takes place in very interesting and advanced components that we call solar cells. And why actually we give this course as a part of master course microelectronics? Because solar cells are from a major part based on semiconductor materials. And device physics and also fabrication processes were developed for the microelectronic industry that the solar cell industry uses now. And the third, people who work in this photovoltaic area feel that they have some noble mission to really solve these problems or contribute to solving these two major problems that I showed to you. So to summarize, why solar cells? First, we need extra energy, and the best will be that it's clean source of energy, and photovoltaics certainly is. Then ecology. When we have the solar cells and they convert sunlight into electricity, it happens without noise, it happens without pollution. Solar cells have no moving parts, so this is an example of, let's say, second generation of solar cells, flexible solar cells. And as you see, even with this light, you see the blue LED works. When I do this, it doesn't work. So even with light like here, solar cells already work and generate electricity. And the third very important issue is economy. And already today, companies that make solar cells are making a big profit. And probably this is the strongest driving force for developing solar cells. People want to make money, and sometimes they forget this noble mission I talk about. Now that you get an idea about energy consumption, you are young people here, so you see here how much energy you need to live healthy and active life. It is about 2,500 kilocalories per day. Well, you know there are several units how to express energy. Kilocalories is one. So we want to generate electricity. The unit that we use to describe electricity is kilowatt hour. So when we translate these kilocalories into kilowatt hours, it is about 1,000 kilowatt hours per year that young people use. And it is about 120 watts that we continuously use. So actually, our body works like a 120 watt lamp. Yeah? And do you know what for we need this energy? This 120 watts that we use continuously. For sleeping, or for what? So, do you have an idea? No, but I mean you use energy as a person. Pumping the blood around. Metabolism. Any other ideas? 120 watts. You can buy it in a shop, such a lamp, and use it. You will see how much energy it is. Usually we use 40 watts, so this is quite a lot of energy. So what it can be? To keep people alive, well, that's more or less what you say. Heating your body, he's right. So most of the energy that we use is to keep the temperature of our body at 36 degrees. Yeah? When you go out, now it's 10 degrees, we have to keep the difference, 26 degrees. So most of the energy that we use goes for keeping our temperature. Now, let's go from an individual person to the global energy use. We have now more than 6 billion people on the Earth. 6 billion. So actually we could say we can easily calculate what is the energy need of 6 billion people, because we know that an individual person for a healthy life needs about 120 watts times 6 billion, and we easily arrive to a number. I will show you what the number is, but the global energy use today is 120 times 10 to 12 kilowatt hours per year. And when we translate it per individual person on the Earth, it's 19,500, so about 20,000 kilowatt hours per person per year. And a healthy person needs about 1,000 kilowatt hours. So actually we generate and use about 20 times more energy than we need as individuals. And most of it goes to all kinds of luxuries that we enjoy, like cars, and today television sets and so on. Yeah? So we need to take care that we really generate this extra energy to have a comfortable life here. So let's look again to the sun. Can the sun deliver all this energy? And we say yes, because you see the sun generates about 380 times 10 to 21 kilowatts, which means it's about 10 to 27 kilowatt hours per year. The Earth receives 10 to 4 kilowatts per person, and today we use is about 2 times, so about 10 to 0, so 2 kilowatts per person global use. Yeah, it is 20,000. So you see that the sun delivers about 10 times more energy than is the global use. 10 times more. So when we can just pick a very tiny part of the energy that sun delivers to the Earth, then we have no energy problem at all. And now the point is to quickly develop all these solar cells so that they can do the job. And to give you a picture what we actually need for making solar cells this job, of course we need a certain area where we place the solar cells and they can convert solar energy into electricity. And when we assume that the overall efficiency of solar cells is 10%, so it means 10% of the energy in the sunlight is converted in electricity, then we need this area, so 1,200 times 1,200 square kilometers, to supply the energy needs in 2050, which will be about 1,000 ettajoules. Today it's 500, as I showed to you. So this is quite a big area. When you imagine the Netherlands from one side to another is about 300 kilometers. So we need 4 Netherlands to get these 1,200 kilometers. But on the global scale, you see, when we place some of these huge power stations based on solar electricity in the deserts, then we can easily find this area and supply these needs. So the red squares that you see here placed, when we sum them up, we come to this area, and as you see, it's just small dots on the map of the world. So again, sun radiates and delivers enough energy to the Earth to solve the energy problem, and the Earth has enough room to place the solar power stations to generate these energy needs. So that is the message of this short introduction to renewable energies. Are there any questions to it? Okay, then we move directly to photovoltaics. So what is it actually? So we have the source of energy. It's the sun. It's smiling like today. The sun radiates solar radiation. Solar radiations carries the energy. Then we need these solar modules, so not the small units, but bigger units like modules or arrays. And they take care that the solar radiation is converted into electricity. Simple like that. So, what is photovoltaics? Actually, it's a sum of two words, photo and voltaics. Photo comes from Greek language and means light, and volta was one of the first pioneers in the research of electricity. So people put these two words together to create a new word, photovoltaics, which actually covers the area of solar cell energy generation. What is very nice on this technology, that it's direct conversion. So again, this beautiful example, it's small module, light incidence on the small module. Well, now it moves because I move it, but when you fix it, it generates electricity. Do you see the blue light from the LED? You see it all. And no light, no electricity. Very simple, like on that picture. Because do not confuse the solar cells with solar collectors. Solar collectors also use a part of solar radiation, but they use the part that we call heat, and they transfer this heat into, let's say, warm liquid like water. And the photovoltaics will be the main energy source in coming years. So what are the advantages and limitations of photovoltaics? Well, I have already mentioned a couple of them. So advantages, environmentally friendly. Once it's made, it just generates electricity when the light hits the solar cell. Produces no noise, no moving parts, no emissions, no use of additional fuels or water to cool it down. Minimum maintenance. I think this is one of the major advantages of this technology, that it really requires almost no maintenance. Later during the course, I shall show you the example of a simple PV system that I have on the roof here in Delft. I have 3 modules since 2002, and I go to my roof to look at the modules only when I have visitors and they want to see it. Otherwise, no maintenance, that I go and clean it every day. No. The nature takes care itself that it cleans it, and it works perfectly for 5 or already 6 years. So I think one of the advantages of this technology is minimum maintenance. Well, compare it with coal or nuclear power. You really every day have to come with the source and put it in the power station. With solar cells, once you build it, you get guarantee for 20 years and it will operate in 20 years. Of course, there are components that can break, like with a car, but you just replace them and that's it. Electricity is generated wherever there is light. Well, I demonstrated it with this small module. PV can operate even in cloudy weather conditions. Yeah, so no direct sunlight is necessary. Solar cells work also in conditions of so-called diffuse light. So not only direct light, but also diffuse, which is reflected from the earth or from the clouds. And another big advantage is that this technology is modular. And what I mean by modular, Maybe some of you have a small calculator here that runs on solar electricity or has a small watch. So we can design a solar cell that powers such a small electronic equipment. We can make a system that can power electricity of your house, and at the same time we can design huge power stations that deliver electricity for whole villages. That is what I mean by modular. It's really, and what you do, you just take the unit, a module, and you stack more and more modules together to make these large PV systems. Well, of course, everything has also its negative sides or limitations. The biggest of PV technology is that when there is no light, no electricity. Very easy. At this moment, the solar cells are quite expensive. And it means that when you calculate what is the cost of kilowatt hour that you generate with solar cells, the price is about 2 to 5 times more than what you pay for electricity from the net. And this is also the main challenge for us researchers and for all people involved in photovoltaics, to bring the price of solar cells down. Large area is needed for large-scale applications. I show you some of the spots on the map of the Earth, what is needed to get the electricity that is expected to have demand in 2050. So really we need large area. Again, what we do in our laboratories at our university, in the group of Tom or in my group, we look for new materials and for new solar cell structures to make the efficiency of the solar cells higher. The example that I gave you was based on the efficiency of 10%. Today already there are technologies that deliver 20% of electricity on the large production level. Yeah? In laboratory, there are already solar cells that reach 40% efficiency. And so you can imagine then when instead of 10%, we have a solar cell that has 40%, 4 times more, then also the area that is necessary for producing electricity is 4 times smaller. Well, another point is that PV generates direct current. And you know that most of the appliances that we use are based on alternating current, AC. So we need extra components to adapt our PV system to these appliances like inverters. And when we use photovoltaics in areas where there is no electricity net, we generate electricity and we want to use this electricity to, let's say, power the lamps when it's dark, then we need to store this generated electricity. So again, we need some extra storage like batteries. It's not a problem, but it makes the cost of your system larger. Now, how the solar cell operates, I just explain it very quickly, and then we have a break. So, the solar cell operation is based on what we call photovoltaic effect. This photovoltaic effect was observed about 150 years ago by a French scientist called Becquerel. And what he saw, he put some electrodes in an electrolyte, and he measured different current when the system was illuminated and when it was in dark. Yeah, so he observed something, some changes when there was a light applied to his system. Today we have a nice definition of what the photovoltaic effect is, and it is the generation of a voltage difference at the junction of 2 different materials. Please pay attention to this. We need a junction of 2 different materials in response to visible or other radiation. So here is also the trick how to generate electrical voltage difference or electric current in response to the light. We need two different materials. And do you have an idea why? Or what happens at the junction of two different materials? Now, very simple. We have light or radiation. I'll explain in a while that we can describe the electromagnetic radiation in two approaches, wave character, and then as a particle, photon. This photon carries out energy, and electricity means that we have charge carriers like electrons. Yeah? So the solar cell is nothing else. Here is an example that the light penetrates into the solar cell. Of course, we have to generate charge carriers because these carry out the electricity. And in semiconductor material, you know that actually we have two kinds of charge carriers. One is the electron with negative charge, and the other is hole with a positive charge. And when we, by absorption of light, generate these two particles, you understand that we have to separate them from each other, otherwise we cannot use them for carrying the current. Because when we let them stay in close proximity of each other, then they will again kill each other in the process that we call recombination. So we need to separate them to the electrodes. So solar cell is a kind of battery that has a front electrode and back electrode, and all we need to do is to take care that the photo-generated electrical carriers are brought to the electrodes. Electron to one type of electrode and hole to the other type of electrode. How we do it? Okay, that is then the result. But how we separate these differently charged particles from each other? So these are charged particles, electrically charged particles. So what we need to let the particles move? We need to create electric field. Perfect. Because once you place this charged particle in an electric field, one type of the charged particle, negatively charged, will be pushed one side, positively other side. And this is what happens at the junction of two different materials. That at this junction we generate internal electric field, and once the photo-generated carriers come into this area of the junction, they feel the internal electric field and are separated from each other to the opposite sides of this region. So this is the reason why we need two different materials to form the junction and actually to form the electric field there. Okay, I shall stop here. Now we'll have break and we start at 9:45.